Thinking Outside the Universe, Part 3 of 3, Computers, Artificial Intelligence, and the Image of God. In the previous chapters, I talked about reason and math as being things that have their origin outside of the universe. One objection some listeners might have relates to computers and artificial intelligence. Computers exist entirely inside the universe, of course, so if a computer does the same thing a human mind does, then that would be an argument that math and reasoning do not originate outside the universe. Now, the first response to this objection needs to be that computers only do what humans program them to do, and humans program them with mathematical laws. But I'd like to move beyond that in the discussion a little bit. The listener would not be blamed if he supposed that computers think something like we do, though perhaps with not quite the same level of intelligence. This idea has become popularized in so many different ways that it's quite ingrained. In fact, some people even ask the question, when will computers be able to pass up humans? The question itself reveals confusion as to what a computer actually does. I'd like to offer a couple of examples describing why the thing that computers do is not really the same thing as what humans do. Can you multiply two 5-digit numbers in your head and give the correct answer within 1 second and never make a mistake? I believe there are a few human prodigies that do that kind of thing, but I certainly can't, and you probably can't either. But computers have been doing this for more than 70 years. So in a sense, computers passed us up 70 years ago. Let's simplify it a little bit. Can you multiply two 1-digit numbers in your head and give the correct answer within 1 second? I can, and many of you can too. If you asked me to multiply 7 times 8, I could immediately say 56. The computer will do that too. However, the computer is not doing the same thing I am doing. The reason I can say 7 times 8 equals 56 is because way back in elementary school, some teacher made me memorize my times tables. So I have the answer memorized. The computer, on the other hand, doesn't have the answer memorized. Every time you ask the computer to multiply something, it calculates it. The way the computer solves the problem of 7 times 8 is that it first converts 7 and 8 into binary form. Binary form is a base 2 numbering system, a system that instead of having digits from 0 to 9 only has digits 0 and 1. That's convenient for computers because it can be modeled with electric signals on or off, or switches on or off. In binary, 7 equals 00000111, and 8 equals 00001000. I hope I got the right number of zeros there. Whenever a computer multiplies a number by 2, it shifts the number to the left, which is the same as adding a 0 to the end. To multiply by 8, it shifts to the left 3 times, which is the same as adding 3 zeros to the end. Therefore, 7 times 8 equals 00111000. It then has to convert 00111000 to decimal, making it 56. In short, the computer and I get to the same answer, but in different ways. I have 7 times 8 memorized, and the computer calculates it. Now, consider what happens if the problem is a bit more complex, say multiplying 56 times 23. The answer is 1,288. The computer would use the same computational approach, using a combination of shifts and adds to get the answer essentially instantly. But what about me? I'm better at math than some people, and I can do 2-digit multiplication in my head. But I timed myself on this problem just now, and it took me 37 seconds to get the answer. I don't have 56 times 23 memorized. I had to multiply 56 times 2 and then multiply that by 10 and then try to remember that product while I multiplied 56 by 3 and finally added those two products together. What I was doing in this case was to start with what I had memorized, then try to extend that knowledge by computing, forcing my brain to act like a computer. I could do it, but not very well. It took a while, and though I got the answer right this time, I would often get that kind of computation wrong. If I had to multiply 3-digit numbers in my head, I'm not sure I could do it. The bottom line is that when it comes to computing, computers passed this up long ago. When it comes to computing, humans can hold only the palest candle to what even the simplest computers do. Now let's talk about a different kind of example. Computers can be programmed to play chess. Chess is a great game for computers because it is a pure game. No knowledge of the real world is involved. A human knows what a chess piece feels like, and a computer doesn't, but that doesn't matter. The computer doesn't need to know that, and it wouldn't help if it did. So in a chess game between a human and a computer, the human's knowledge of the real world doesn't help the human at all. In 1996, a computer chess match of 6 games was arranged between a computer called Deep Blue, specially prepared by IBM to play chess, against the then world champion Garry Kasparov. Kasparov won the match. IBM went back to work, and the programmers strengthened their program, and in a 1997 rematch, Deep Blue won. It was hailed as an important and momentous occasion since computers had now passed up the best chess-playing human in terms of chess-playing ability. However, I think the way we are looking at this story is upside down. How could a human hope to even compete in a chess game against a computer? You see, what not many people understand is that when a computer is playing chess, it is not doing the same thing that humans do when a human is playing chess. As an illustration, I selected a position from Game 6 of the 1997 Kasparov Deep Blue match. If this is White's move, he has a lot of choices. Each choice of moves could lead to advantages and disadvantages. How many potential chess moves do you think you could evaluate in 1 minute? I asked my son, and he said he could evaluate 10 moves in 1 minute. That seemed high to me, but let's go with that. In this particular position from the 1997 match, I counted 41 possible moves for White. I may have counted wrong, but if that's wrong, it's still close, and it's still representative of what you would commonly see in the middle of a chess match. At the moment, it looks like Black has 37 possible responses, though that would change a little based on where White moves. Therefore, after 1 move by each player, there are 41 times 37 possible positions, or over 1,000 possible positions. After 2 moves by each player, there will be over 1 million possible positions, and after 3 moves, there will be over 1 billion. It is safe to say that no human chess player is evaluating 1 billion possible positions. However, that is what Deep Blue was doing. And it could look more than just 3 moves ahead, and it could do it in just a few seconds. The computer looks at every possible move and evaluates how strong it is after each one. It does this by assigning a numerical value to each piece, something like a pawn equals 1, a knight equals 3, a rook equals 5, and so on. Deep Blue will look as far into the future as its computing power allows and pick the move that gives it the best numerical value. A chess computer's human programmers will enhance the computer's ability by providing it with a set of the best known chess game openings to help ensure that the computer never gets started on the wrong foot. Furthermore, within the limits of this kind of program, the computer will never make a mistake. It will never accidentally put its queen in the path of a knight or anything foolish like that, which human players do from time to time. So given all of that, maybe we are looking at the human versus computer chess match all wrong. How is it that a human ever managed to beat a computer in the first place? How did we keep this advantage all the way until 1997? Garry Kasparov was not evaluating 1 billion positions or 1 million or even 1,000. And unlike the computer, Kasparov could certainly make a mistake. The computer never did. To play chess, the computer is computing. The human is not doing that very much. The human player will have learned some principles about chess. The principles will be things like, don't bring your rook out too early in the game because it's likely to get trapped by pieces of lesser value. On the other hand, at the end of the game, it's best to have your rook ahead of your pawns rather than behind them. A human is likely to apply those principles when making a move, though they are hard to quantify. It may be far into the future before the principle produces any material advantages that a computer could see. Furthermore, a very advanced human is doing something else that you and I do not do, and the computer doesn't either. I once played a chess game against Susan Polgar when she was 17 years old. At the time, she was the top-rated female player in the world, though her younger sister Judith soon passed her up. I lost, by the way. Susan once participated in an exercise in which she sat in an outdoor cafe as a truck drove by. The truck had a chessboard painted on its side with pieces in a position for the middle of the game. Though Susan only saw the truck for a moment, she was able to correctly recreate the position on her own chessboard. Next, the exercise was repeated, but this time the chess pieces were in a position which was not possible. For example, a pawn can never be on the first rank since pawns start on the second rank and can only move forward. Susan was not able to recreate the illegal position. Further study has shown that very advanced chess players like Susan Polgar actually have adopted the facial recognition portion of their brain to recognize chess positions. Humans may not be very good at computing, but we're great at facial recognition. If we once meet someone and look well at their face, we're likely to recognize that same face for years, even if we don't remember their name or where we met them. So humans playing chess don't compute much. They compute a little bit, but they choose largely based on principles, with the best players recognizing positions and partial positions with the facial recognition portion of their brain. Speaking of facial recognition, computers are beginning to do that too. How do computers recognize faces? Facial recognition software makes lots of three-dimensional measurements on the face, closely measuring things like the distance between the eyes, the width of the nose, the depth of the eye sockets, etc. How does the human brain recognize faces? It's not the same way. Neither you nor I are measuring the length of someone's jawline in order to recognize them. The conclusion I'm trying to get to is this. Computers compute, while the human brain computes very little and not very well. What the human mind does is different, and the human brain to computer analogy is not as strong as we often think it is. Everything that goes on inside a computer is obviously part of the physical universe, but the human mind is very different from a computer. So some of the things that happen in the human mind can have originated outside of it. Suggested reading on this subject would be the book Computer Power and Human Reason by Joseph Weizenbaum. It's quite an old book for one on computers, but don't be put off by that. Mr. Weizenbaum says much of what I was trying to say in this section, but he does it much more clearly than I did. Chapter 6. The image of God. Why do people laugh at dirty jokes? What is it that makes them funny? Now, before I seriously explore this question, let me say that I have been conditioned to not laugh at dirty jokes. I certainly don't tell them, and I try not to laugh at them, and I hope you do too. But this is a result of training, and if you are not trained to look askance at dirty jokes, you too will be inclined to laugh at them. So to return to the question, what makes a dirty joke funny? One of the things that makes us laugh is when we see something that seems ridiculously out of place. If you go to the circus, you may see a bear dressed up in a ballet costume and standing on its toes. If you do, it will strike you as funny. The ballet costume on the bear is ridiculously out of place. I would suggest that this is what makes dirty jokes funny. Dirty jokes focus on people, but always on the earthy, physical, and animal-like qualities and functions of people. And this is funny because it seems out of place. We all know deep down at some level that humans have some higher and more transcendent quality than what is described in the dirty joke. The Bible calls this quality being created in the image of God. However, the Bible also says we were created from the dust of the earth, the same stuff as the animals. We are animals, and dirty jokes remind us of that. But we are also something much greater, eternal spiritual beings created in the image of God. It's an image that came all the way from outside of the universe. The earthy nature seems way out of place sometimes on a spiritual being. It's like the bear in the ballet costume. It makes us laugh, as long as we're not offended. So next time someone tells you a dirty joke, maybe you can explain to them how they've just provided an argument for the image of God. The image of God is on all of us, and it's extra natural. Maybe some of you have had a well-loved pet that got very old. I have. Eventually, the pet begins to suffer from one of the ravages of old age, and you have to make the painful decision to have the animal put down. You take your pet to the veterinarian, and the vet kills the pet in the most humane way possible, and you cry about it. The thing you are doing is not cruel. You are doing it out of love. Your animal's quality of life is gone, and you don't want your animal to suffer. What happens when a human being gets old and begins to suffer in the same way? It's very painful for all concerned, but generally, we do not make the same decision that we do for our animals. We are likely to choose palliative care to minimize our loved one's suffering, and we may opt for no heroic measures to maintain and extend the life of a loved one, but we do not, at least most of us do not, choose to kill them. Why not? We love them. We don't want to see them suffer. We may even pray for their life to end. But killing them is something we can't do. We can't do it. The reason is that every human being carries the image of God, something so great and extra natural that we dare not, we have no right to end it. The image of God is on all of us, and it's extra natural. I hope you've enjoyed this discussion of things outside the universe. I know I haven't covered them all. A good case could be added for making extra chapters on things like faith, hope, and love. I'll leave that for someone else. Thanks for listening.